Hello, today we talk about the electric vehicle revolutions and its implication for companies participating in this exciting space. First, the global EV sales reached 10.5 million units in 2022, a 55% increase from 2021. The market share of EVs in new car sales globally surpassed 13% in 2022. The biggest country for EVs would be in China, in Europe, and in the United States. So if you have a limited budget, I would focus on those three countries. Of course, Japan, Korea, they're also important. And of course, in 2024, we see Tesla and all sorts of electric cars parading through our highways. The major players are Tesla, and in China it's BYD. Then there's also virtually all of the major car companies participate in this exciting segment. So EVs are important in sustainable transportation. There's a potential to reduce greenhouse gas emissions by up to 50% compared to conventional vehicles. EVs plays a big role in achieving climate goals and reducing air pollution in urban areas. There are many government incentives and regulations driving EV adoption. Next, we talk about how to maximize the intellectual property opportunities during this exciting shift to EVs. Patent strategies for EV technologies can focus on the battery innovations, the motors, and the charging system. There are exciting areas that are growing in solid-state battery, and of course we want cars that can drive longer range and last longer, just as in our phones and our laptops. There's significant opportunities in batteries with a high energy density, fast charging technology. Also, motor efficiency can be improved, and that concurrent with the power density issue. So if you have a more efficient motor, then your existing battery could last longer. The power density is also important in enabling the car to have more horsepower, for example. And of course, these cars wouldn't operate long if we weren't having a good charging infrastructure. So there are significant opportunities in wireless charging of cars, also opportunities in terms of charging, the transferring the cost of charging the car. The importance of a comprehensive IP portfolio in this space cannot be underestimated. There are needs for both defensive and offensive patent strategies. As an example of a defensive strategy, if you are a small new company coming into a space where the big companies have thousands of patents, you want to bulk up fast in case they come after you to knock you out of the marketplace, that you have something to negotiate. So that's defensive side of it. There's also the offensive side of patents. If, let's say, your competitors copy from you, you want to offensively use your patent to block them from doing that, to protect your technology and the exclusivity provided by such investments in R&D. So that's offensive use of the patent, is to protect your market. A diverse patent portfolio has significant value because you don't want to be betting everything on one horse, just like you don't want to invest only in one stock in your portfolio, in your stock portfolio. You want a diverse set of patents. And as we discussed, improvements can be in the navigation aspects of the electric car. It can also be in battery technology, in charging technology, and in the motor technology. There could also be innovations in AI-related aspects to the technology. And when you have a large portfolio, they're more reliable and more stable than when you put all your hope into a few patents. When a competitor comes into the space and they see 50 patents, it's going to be hard for them to argue that all 50 patents are invalid. They can say, maybe a few of them, but it stretches the mind to say all 50 patents are invalid. That means when they come in to copy you, they will have to be very mindful of your IP portfolio. And that means that they will need to do a design around analysis. Now, a design around analysis is simple if you have only one patent. But when you start having a giant portfolio with many different dimensions, that becomes exponentially harder. The diverse patent portfolio provides you with more legs and more sustainability and defensibility of your overall portfolio. Now, if you have a big portfolio, you can get licensing revenue and cross-licensing opportunities. You can license the technology and earn money from your competition. You can also enter a space where your competition may already be there through cross-licensing your technology with their technology. You need some sort of a trading card. Next, let's talk about emerging IP trends in the electric vehicle industry. As we discussed above, the EV industry is growing rapidly, and concurrent with that is the patent applications in recent years. Leading countries and companies in the EV space would include companies such as Tesla and BYD. There's a shift that's going on from traditional automotive patents to EV-specific patents. The reason for that is that all the big companies have stated their intention to phase out their ICE engine technology and transitioning over to EV because of customer demand and also environmental issues. There is a decline in fossil fuel vehicle, and because of that, there's also a corresponding decline in the fossil fuel patents in that space. You may have some patents for the fossil fuel. During this transition period, what you can do is repurpose some of your fossil fuel engine patents into the EV application, maybe perhaps in the form of a hybrid vehicle where over the next few years there's going to be a transitional period. And so your existing fossil fuel patents are still applicable, although long-term we expect that to drop. What are some of the key areas for IP protection? Certainly, as we mentioned, battery technology and management system. There's significant innovations in the cathode and anode materials, electrolytes, and cell design. There are also technologies for battery thermal management and safety system. We all hear about lithium batteries catching fire or exploding in a fire. And of course, when you have mass use of the lithium technology, you need to address the safety issue. There's the issue of battery recycling and second life applications. We have all these cars on the road, and the batteries ultimately last about 5 to 10 years, and then they will have to be trashed, and that eventually will cause an environmental problem. A number of companies are now working on recycling the batteries, and the advantage would be, of course, we reuse the material, it'll be cheaper, and it will save the environment. So in addition to recycling, there's also technologies to provide second life applications for batteries that may not be suitable for heavy duty vehicle application, but it may be useful for, let's say, cellular or for other consumer application. That's another good area to look at. As far as the charging infrastructure and the protocol, then there's a significant need for technologies covering charging station design and communication protocols. So there are a number of companies that are working on fast charging technologies and wireless charging systems. These patents and the new technologies need to address also the issue of interoperability and standardizations. You would not want a Tesla to go only to a Tesla charging station and a Mercedes to go to only a Mercedes charging station. That will cause balkanization of the charging, and it would be unnecessary. There will be exciting opportunities for interoperable and standardized recharging stations. Now we talk about autonomous driving features for EVs. There is also exciting intersection of EV and autonomous vehicle technologies. There are a number of patents that are relating to energy efficient route planning and battery management for autonomous EVs. For example, if you know that your battery is going to last only to a certain mileage, you would route the vehicle that it lasts exactly just to that last ounce of energy, and then they can get recharged. There's also new business model and services enabled by autonomous EVs. One problem we have is that most cars are simply parked in garages, and there is a transition toward non-ownership of the cars, but using these cars as smart cars, as taxis. You have transportation service on demand. That will cut costs down because now you don't have to own a car. The cars that comes and pick you up, they're all neat and new and they're fresh. And you get exposed to the latest technology, and it's being used by everybody on a high frequency basis. Therefore, the cost will be competitive with owning your own car. That's an exciting area of transitioning. And also, a number of companies are now talking about providing downloadable services onto the car. Let's say if you want self-driving car, you can buy that, and it would turn on the software that's already in your car. And let's say if you want to be able to turn this into a small home entertainment system, you can turn on that feature, and then your vehicle display and the sound system can be optimized according to the payment level. That's an example. Next, let's talk about collaborative IP strategies. You want to look at strategic partnerships and cross-licensing agreements. There are examples of highly successful collaboration in the EV space. So, for example, Toyota and Panasonic collaboration, Ford and Volkswagen, numerous other examples exist. And when you cross-license, you can accelerate innovation and reduce litigation risks for the companies. There's also various open innovation initiatives in the EV sector. You can look at examples like Tesla's open source patent pledge. That provides Tesla with an advantage because as a new entrant, they don't want to be sued by other companies. On the other hand, they still need a significant patent portfolio, because if you sue them, then their open source patent pledge will go away. And so you need to balance that open innovation with protecting your core IP assets. And there are certain things you don't want to be available for open innovation because that's protect your core business where you derive a lot of value from. However, you can contribute non-core assets to encourage innovation in the EV sector.